Right now, as you watch this video, Saturn is losing its rings. Not in 1,000,000 years, not in 1,000. Scientists say they could be completely gone within 100 million years, and that process has already started. The most iconic image in our entire solar system is slowly vanishing, and almost nobody on Earth is talking about it. Saturn formed approximately 4.5 billion years ago, born from the same swirling cloud of gas and dust that gave birth to every planet in our solar system. It is the sixth planet from the Sun, sitting at an average distance of approximately 1,400,000,000 kilometers from Earth. It is a gas giant, meaning it has no solid surface to stand on. If you tried to land on Saturn, you would not touch ground. You would simply sink deeper and deeper into layers of hydrogen and helium until the pressure crushed you, long before you reached anything resembling a core. The planet is enormous. More than 700 Earths could fit inside it. Its winds scream. At speeds exceeding 1,800 kilometers per hour, its storms have been raging for centuries. And yet, for most of human history, when people looked at Saturn through a telescope, they did not talk about any of that. They talked about the rings. The rings of Saturn are one of the most recognizable structures in the known universe. They stretch outward from the planet's equator across a distance of approximately 280,000 kilometers. Nearly 3/4 of the distance from the Earth to the Moon. And yet, despite that incredible width, they are almost impossibly thin. In most places, the rings are no thicker than 10 meters. To put that in perspective, that is roughly the height of a 3-story building, spread across a structure wider than 500,000 football fields laid end to end. The rings are made almost entirely of water ice, particles ranging from the size of a grain of sand all the way up to chunks the size of a house. They shine because they reflect sunlight with extraordinary efficiency. That is why Saturn glows the way it does. That is why it looks the way it does in every photograph ever taken. That brilliance is borrowed light, bouncing off billions of pieces of ancient ice. And that ice is falling into the planet right now. Scientists at the National Aeronautics and Space Administration confirmed what had been theorized for years. No, the rings are not permanent. They are not some timeless feature of the solar system. They are relatively young, formed somewhere between 10 million and 100 million years ago, which in cosmic terms is practically yesterday. And they are already in the process of disappearing. The mechanism is called ring rain. Saturn's powerful magnetic field charges the ice particles in the rings. Once charged, those particles are drawn downward along magnetic field lines and pulled into Saturn's upper atmosphere, where they evaporate instantly. The National Aeronautics and Space Administration's Cassini spacecraft, which spent 13 years orbiting Saturn before its mission ended in 2017, measured the rate of ring rain directly. The results were startling. Saturn is losing between 10,000 and 45,000 kilograms of ring material every single second. Every second. That means that every year, Saturn is shedding billions of kilograms of the very material that makes it the most visually stunning planet in our solar system. If you were floating in space just outside the rings right now, you would not see this happening with your eyes. The rings would look solid, radiant, almost too beautiful to be real. You would see bands of pale gold and gray and white stretching out in both directions until they vanished into the distance. The sunlight would catch the ice in a way that makes it look like the entire structure is softly glowing from within. But beneath that surface beauty, at a scale too vast for human perception, the slow erosion is constant and relentless. The outer rings are thinning, the gaps between ring bands are widening. Cassini's final measurements showed that in geological terms, this process is accelerating. Scientists now believe the rings may be completely gone within 100 million years. Some more aggressive models suggest it could happen in as few as 30 million years. Either way, in the timeline of the universe, Saturn is already losing what makes it Saturn. What would it actually be like to descend into Saturn's atmosphere? The question sounds like science fiction, but physicists have modeled it carefully. The moment you entered the upper cloud layers, the temperature would be approximately minus 130 degrees Celsius. The sky above you would shift from black to a pale amber haze. The winds would immediately begin pushing you sideways at speeds no human-built vehicle has ever survived in an atmosphere. As you descended further, the pressure would increase rapidly. At around 300 kilometers below the cloud tops, the atmospheric pressure would reach 100 times what you experience standing on Earth's surface at sea level. At that depth, the hydrogen around you would begin to behave strangely. No longer a gas, but a fluid that conducts electricity like a metal. Your spacecraft would be crushed, dissolved, and absorbed into the planet before reaching anything that could be called a surface. There is no surface. There is only increasing pressure, increasing temperature, and increasing density. I'd all the way down to a rocky core, roughly the size of Earth, that sits at a temperature of approximately 11,700 degrees Celsius, nearly twice the temperature of the surface of the Sun. No life as we understand it could exist on Saturn. The conditions inside the atmosphere are incompatible with any biological chemistry known to science. There is no water in liquid form. There is no stable energy source that a living organism could harvest. The pressure gradients shift too rapidly. The chemical environment is too hostile. However, some researchers have speculated that in very narrow altitude, bands in the upper atmosphere, where temperatures and pressures are slightly less extreme, complex organic chemistry might theoretically be possible. It is a long way from speculation to confirmation. And no credible scientific institution currently claims life exists on Saturn. But the fact that the question is being asked at all speaks to how strange and rich this planet truly is. Now, let us talk about the part of this story that almost nobody discusses: the money. How much would it actually cost to send a crewed mission to Saturn? The honest answer is that we do not currently have the technology to do it. But scientists and engineers at institutions including the National Aeronautics and Space Administration, the European Space Agency, and private aerospace companies have run the numbers on what it would take. The figures are almost incomprehensible. The Cassini mission, an uncrewed robotic spacecraft, cost approximately $3.26 billion United States dollars from development to end of mission. Well, that included the spacecraft itself, the Huygens probe it carried to Saturn's moon Titan, launch costs, and 13 years of operational support from ground teams. And Cassini was not designed to enter Saturn's atmosphere intentionally. It was designed to orbit. When the mission ended, controllers deliberately steered it into the atmosphere to prevent contamination of Saturn's moons, and it was destroyed in seconds. A crewed mission to Saturn would be categorically different from anything humanity has attempted. The distance alone is the first problem. At its closest point, Saturn is approximately 1,200,000,000 kilometers from Earth. At average distances, using current chemical rocket propulsion, a one-way trip would take approximately 6 to 8 years. For context, the longest continuous human space flight on record is approximately 437 days. A crewed Saturn mission would require keeping human beings alive and psychologically functional in deep space for more than a decade round trip, with no possibility of rescue and communication delays of up to 1 hour and 24 minutes each way. The spacecraft required would need to carry enough food, water, oxygen, and fuel for the entire journey. It would need radiation shielding capable of protecting the crew from years of deep space exposure, where radiation levels are many times higher than those on the International Space Station. It would need redundant life support systems, medical facilities, and a psychological support infrastructure that does not yet exist. Engineers at the National Aeronautics and Space Administration have estimated that the mass of a crewed deep space vessel capable of a Saturn mission would need to be somewhere between 500,000 and 1 million kilograms in low Earth orbit before departure. Getting that mass into orbit using current launch technology would require somewhere between 50 and 100 heavy-lift rocket launches. At current pricing for heavy-lift launches, that component alone would cost between 15 and 30 billion United States dollars before a single astronaut had left Earth orbit. Total mission cost estimates for a crewed Saturn orbiter, not a lander because there is nothing to land on, range from 100 billion to over 250 billion United States dollars when accounting for spacecraft development, crew training, mission operations, and the new propulsion technology that would be required to make the journey survivable. That figure is roughly equivalent to the entire annual defense budget of the United Kingdom. It is more than the total combined revenue of the world's 5 largest technology companies in a single year. It is, by any measure, the most expensive thing a human civilization has ever attempted. And yet the engineers and scientists who work on these proposals argue consistently that the scientific return would justify every dollar. Saturn's rings alone represent a laboratory for studying planetary formation that cannot be replicated anywhere else in the accessible solar system. The data Cassini collected in 13 years of orbital science generated over 600 scientific papers and fundamentally changed our understanding of how ring systems form, evolve, and die. A crewed mission with the ability to deploy instruments, collect physical samples, and respond to unexpected discoveries in real time could produce a scientific revolution on the scale of the Apollo program. The question is not whether it is worth doing. The question is whether any nation or coalition of nations is willing to commit to the timeline and the budget. Based on current projections, the earliest realistic window for a crewed Saturn mission using technologies currently in development would be somewhere in the range of the 2070s to the 2090s, assuming funding remained consistent for 50 years, which no space program in history has ever managed. Saturn has been out there for 4.5 billion years, and for most of that time, it had its rings. Now we know they are temporary. The most iconic structure in our solar system is slowly vanishing, and we are the first generation in human history to know it. The clock is running. If this video changed the way you see the universe, hit that subscribe button right now. We are just getting started.